Good morning. Chapter 9, Lesson 3 is on page 412, and we're going to be doing equations in absolute values today. The interesting thing about absolute values is we usually have two values for these absolute value equations, because sometimes we can have values that are both negative and positive inside the absolute value, and when you evaluate those become positive because they are defined as the distance from 0 on the number line. So let's begin with the first problem, number 23, the absolute value of 3y minus 2 plus 4 is equal to 21. So what we're going to do is first simplify this. So we're going to make the absolute value of 3y minus 2 plus 4, take away 4, is equal to 21, take away 4. So we end up with the absolute value of 3y minus 2. Turns out to be equal to, I believe it's 17. So we have this now that we can manipulate, and that breaks out into two equations. 3y minus 2 is equal to 17, or we can have 3y minus 2 equals negative 17, because we remember we can have two values for the absolute value. So let's see if we can solve this one. So we have 3y minus 2 plus 2 is equal to 17 plus 2. So we end up with 3y is equal to 19, or y is equal to, I believe, 19 over 3. On the other side, we have 3y minus 2 plus 2 is equal to negative 17 plus 2. So we end up with 3y being equal to negative 15. And if we divide both sides by 3, y turns out to be negative 5. So the solutions to this problem number 23 have two values. So the solution set can be considered negative 5 and 19 over 3. So there's our answer for number 23. Two values, absolute value. Number 35, we do exactly the same thing. We're going to make this x minus 4 is equal to x minus 4 is the first equation. And the second equation is x minus 4 is equal to the opposite of x minus 4. Because we have two values, just like we had the 17 here and we made a negative 17, we'll do the same thing. First we have the value x minus 4, and then we have its opposite. So this one over here means not a whole lot comes up. So x minus 4 is equal to x minus 4, 0 is equal to 0, 1 is equal to 1, 2 is equal to 2. That doesn't really help us. Let's go on to this one. X minus 4 is equal to minus x, and if I distribute, remember, a negative 1, if I can put that in there, minus 1x plus 4. So we end up with that. So if I add x to both sides, I end up with x minus 4 is equal to minus x plus 4. I'm kind of doing the gory details here. I'm sorry, and I need to add the x on this side as well. So I end up with 2x minus 4 is equal to 4, or we end up with 2x is equal to 8 if I add 4 to both sides, or x is equal to 4. So with first part of the problem, we came up with nothing that really helped us, but in the second part it said x is equal to 4. Now the interesting thing about this problem is if we take a look at it, 4 definitely works. 4 take away 4 is equal to 0, and 4 take away 4 is equal to 0. But because this is an absolute value, it turns out that if you stare at it for just a minute, any number that you put in here greater than 4, like 5 take away 4 is 1, 5 take away 4 is 1, is going to work. So the solution for this one turns out to be x is anything greater than or equal to 4 is the solution for number 35. Interesting problem. This first part really didn't help us out, but when we're done with the second one, we end up with x equals 4. But not only will 4 work, anything larger than 4 will have a solution as well. That's it for today. Thanks so much.